So we're going to open up a new window in GC. And here we go. So the height of a sunflower in centimeters T days after the seed germinates is given by this formula. Height equals this formula here. The formula is only valid for the first 10 days after germination. So I'm going to have you guys work on one question at a time. First one is, in GC, define a function named K that relates to time and days since germination, and that's the independent quantity, and I want you to use D for that. And it relates that quantity to the height of the sunflower in centimeters as the dependent quantity. So I want you to define a function in GC. The name of the function is K. The independent variable is D. That's the number of days. And this function relates number of days to height of the sunflower. Okay, do that in your first line in GC. Do that. And whenever I just give you tasks in class, you're free to talk to your neighbor if that's what you want to do, unless I say otherwise, okay? So this isn't a quiz anymore, so just when I give you tasks, you're always free to consult. Where is Fatma, Rahi? Did you get it? Still working on it. How about Derek, Tran? Derek. Where's Derek? I heard someone say, oh, right there. Did you get it? Tell me. K. Control 9. K of D equals
0.1 D cubed plus 1.7 D squared minus 0.6. And then we have a new line like this kx. And then
oh, we're just defining the function. No, not graphing it. I don't want to display the graph. I just want to define the function. So this is what he did.
there's also the main that you have to put in.
Okay, so we can do that in the definition, or we could do that when we graph it. So yeah. Thank you. I just thought it was your teacher error there. Okay. How'd he do?
Yeah.
This is the definition of a function named K. So notice, when I gave you this height formula, that was just a formula. That wasn't a function. That was just a formula that gives you the height. Now it's a function. Now we've defined a function named K, and the independent variable is D. That's the number of days. The dependent variable, so this is the next question. So, based on the function definition, what is the variable whose value is the height of the sunflower D days after germination? So based on that definition that we just defined, what's the variable for the height of the sunflower D days after germination? Where's Glenn? Firm. Glenn, what do you think? What is the variable for the height D days after germination?
The variable D.
What's that?
The variable is D.
The variable is D. Agree with that? Variable is D for the height. No, the D variable is the number of days since germination. Where's Ryan Thompson? Ryan, what do you think? What's the variable for height? He wants K of D. Agree with that?
Yes.
That's it. So now that we've defined this function, K of D is our variable for our dependent quantity, and that's the height D days after germination. And so if I just type in K of D, if it's a variable, why did it give me the value 1? Why did it give me the value 1? Do you remember what we talked about last time?
Because you haven't assigned a value to it.
Yeah, so in the first line, the D is just a placeholder. It doesn't have a particular value. It's just our placeholder for the independent variable. In this line now, it's actually looking for a value of D to plug into K and give us a height. And it did. So since we haven't defined d, it plugged 1 in. And it just happens with this particular function, if you plug 1 in, you also get 1. So this is the value of k of d of 1, not the fact that d is 1. So what if I want to know what the height is after 7 days? Okay, I could do k of 7, or I could just do d equals 7, and then look what happens to the previous line. Yes, so I could have done k of 7, or I can now tell GC, I want d to be 7, and then it's going to update what k of d is. So what's the height at 7 days is 44.8 centimeters. Make sense? Okay, next task. Here we go. Display the graph of k in GC for the first 10 days after germination. And then you're going to adjust your window. I'm going to show the graph, and you're going to adjust the window to match, use the zooming capabilities to match the display that I show. Okay? So you're going to display the graph in GC for the first 10 days. And do you remember how to use the zooming controls to match this axis scale? So get your scale on your x-axis to be what I'm showing, 2, 4, 6, 8. And then on the y-axis, 10, 20, 30, 40. So yours looks just like mine. But you're going to have you should just get this view, okay? There we go. So if you do it correctly, it should look exactly like this. If you do this part C correctly, it should look exactly like this. We'll take one pass around. Let's see. Show me your graph. Same scales on the axes. If you have a question, make sure you ask. Okay, so remember, that's the view window. Okay, so how do we do this? So to graph, what? We want to take the dependent variable and put it on the y-axis. And then we want the independent variable on the x-axis. So we're going to take our function definition. If we want the dependent variable on the y-axis, then we're going to say y equals k of, and then we want the independent variable to be x. So this is doing exactly that. It's going to take the independent variable, put it on the x-axis, and then take all the values of the dependent variable and make them equal to y. But then we only want to do that for 0 to 10. So that, and then you're going to adjust the axes with your zooming and get it to look just like this. Okay. And then we talked about that when you see this, what do you think? So when you see a graph, or any graph like this, a curve, a line, you see this and you think what? What is this really portraying? What is it really displaying? Yeah.
A sequence of points.
Right. This is what we're really seeing is a bunch of points. We're really seeing a bunch of points. Okay? Each point is a correspondence of a number of days and a height of the sunflower. Okay? And then even better way to visualize this is if you imagine it this way. Here's the very best way to imagine that. The graph that you just plotted, just the static curve, is that variables vary. Variables vary, and so as time goes by, all these correspondence points are generated. Points of time since germination and corresponding height as that time variable increases. So this is the very strongest image or visualization of this that there is, okay? So when you see things like this, you think of correspondence points being revealed as the independent variable increases. Okay, was there a question up here?
No.
Okay, you good?
Yeah.
Okay, next task. I want you to write a command line in GC to highlight. We know this is a bunch of points. Now we want GC to highlight a point for us. The point associated with 7.263 days after germination. Can you highlight the point on the curve that's associated with 7.263 days after germination? Remember how to do a point. Remember how to plot a point. And I want the exact correct point. And I want to do this in the most efficient way possible.
I'm not Samuel.
David Samuels. David Samuels. Okay, Ashley Russell. Okay, how did you get? Were you able to highlight that point?
No, I'm kind of confused because I don't know which thing to put inside where the D is. Wait, I'm confused because I don't know if 7.263 is the day or the height. I just don't.
Oh, okay, so yeah, so if you have a question during this open time, raise your hand. Get your questions answered so you're not idle, okay? Get your questions answered. Okay, where is it's the days. So 7.263 is the number of days. And so where is Jia Yao? Jia Yao. Yeah. So were you able to plot this point that highlights this time and height? Were you able to plot this point? Right? Good. So you're going to do Control 2, and you're going to have 7.263, and then your y coordinate will be of that point k of 7.263. K of 7.263, and that will give you that point right there on that curve. Okay. So any questions on that? And we didn't add a point. We just highlighted a point that was already there, right? We're just highlighting a point that was already there. Because what is that curve? It's an infinite number of correspondence points. Okay, next task. Ready? I'll show you on the screen and then you're going to do it. Ready? So now I want to highlight that point even more. I turned it off. Yeah, thank you. Okay, now I want to highlight that point even more. I want to add this blue bar and this red bar to highlight those values of D and the height, K of D. So, this blue bar and this red bar are no different than that. They're both, this is just a new set of points. That blue bar is just a new set of points. What mathematical statement defines that set of points? And then what mathematical statement will define that set of points? So you're going to write 2 more command lines to recreate these segments that are further highlighting that point that we just found. Okay? Here we go. Important task. Very important task, so you know how to do this. Did I say your name right? Katya? Katya, okay? How'd you do? Let's listen up. Here we go. Okay, so she said y equals k of 7.263. And is that going to give us the red or the blue? Y, yeah. So if you do y equals, you're saying I want all points whose y value is that function value. Okay, and then? Yeah. Awesome. And so the same way that we just took part of the function curve, we're just going to take part of that line. So what part do we want? Starting at 0, ending at 7.263. So that's going to be our x domain. Okay, you're on a roll. Keep going. Did you get the other one?
And then for the other one, the blue line I put x equals 7.263, and the range I put 0 less than or equal to y less than or equal to k of 7.263.
Awesome. Okay, so now we want all points whose x-coordinate is 7.263. So we say that x equals 7.263, but then we only want it from, now this is going to be a range of y values, right? We want it from y equals 0 up to, and what's my highest y value for that? K of 7.263. Okay, so then the next step, we won't do it here in class, we want to move on to the other thing, would be make that point movable. So that n, your n slider, is the number of days. And when you change the n slider, it's going to highlight different points on here according to the number of days. And then along with that, have your blue and red highlighting segments stay with the current value of or the current location of the point. We won't do it now, but that'd be a good little task. And that's related to what you'll do for the activity that you're turning in next Wednesday. Okay? So rather than have it be static at 7.263, could you make that a maneuverable point using n as the number of days? And likewise, that these highlighting bars would come with it as you changed n. That would be the next task in this. Okay, any questions on what we did here? Before we move on. Okay. So we're going to kind of change gears a little bit here. We've talked a lot about function notation. Let's do something new here. So I've got this variable z. And z I'm defining as the used memory space on your smartphone in gigabytes. Okay, the used smartphone memory space, use memory space on your smartphone in gigabytes. And then I've got this number line, okay, and I have a red bar. And I have a what's going on? Didn't get saved with my changes. I'm going to do this. Let's see. That's why. Let's try that. That's what I wanted. Okay. So I'm showing a red bar and a blue bar, which are related to this variable z. So let's talk about the red bar. What could the red bar be representing? What could the red bar be representing in this visual here? Yeah.
We currently use memory space.
Okay, and so how can we represent that? How do we represent the currently used memory space?
Z.
Z. So the red bar, or the length of the red bar, is our variable z. Okay? So if the red bar is currently used as a value of z, what could the blue bar then represent in this situation? Somebody knew. What ideas?
Maybe the total amount of memory space left.
Total amount left. Okay? Other ideas? So if this is, so you're using 6 gigabytes on your phone right now. That's the value of z. So then what would that blue bar then represent? Yes, sir?
Make the value of file you're put on it.
Okay, yeah, like so it'd be like a value of a file that you're about to put on. Is that a value of Z?
No.
No, because Z is the total amount used. So we need something different for this. So it's like, yeah, so we're about to download a file, and this is how big that file is. So when we're all done, we're going to have, what, 8.5. We're here at 6. We're all done. We're going to have 8.5. So what does that blue length represent? How can we kind of just summarize that? Yeah.
It's the difference in the
Right? And so the difference would give us the change, right? The change. So this blue bar is the change, and we use dz to mean the change in the amount of a variable we've already defined. So we've defined z as, I think they're both going on there. Z we define as total use smartphone memory space. dz would be a change in that value of z. dz we represent as a change in that value of z. So what's the current value? 6. What's the change in the value of z, or dz? What is it now?
2.5.
2.5. Do you see that? And so then the new value of z after the change would be what?
8.5.
8.5. Do you see that? Okay, get out your sheet. Is there an extra one for me? Is there an extra one lying around? Okay, look up the top. So there's a bunch of questions here, so don't get ahead of me. For each question, 1 through 6, you're going to read the description about the smartphone, and you're going to assign a value of an initial value of z, whatever it is in that situation, the final value of z, and then the change in z. So you're going to be given the situation in the line. You're going to fill in the values for z initial, z final, and the change. One of those, two of those you'll know the value of, and one of them you won't. Okay? So one of those values will be unknown, and the other two you're going to fill in. Then you're going to write, you can figure out what the unknown one is, and then write a general formula that would solve for the unknown. So do the first one together. So at first, 3 gig of memory is being used. So I'll show you that here. Okay? And then it says, after you download a file, 5.5 is being used. Okay? So, do we know z initial?
Yeah.
And it is 3. You fill in 3. Do we know z final? 5.5. It's known. Okay? So initially here, dz is not known, right? But you can very quickly figure it out. dz equals 2.5. So now in that box, because dz was the unknown, you're going to write dz equals. dz equals, because it was the unknown. And then you're going to write a formula based on the z's that would calculate that dz. Or we're kind of formalizing what did we do in our head to get that value of dz. So you're writing a formula, dz equals, in terms of the zi and the zf.
Yeah.
Okay, so what do you do to zi and zf to get dz?
Yeah.
Yes? She wanted zf minus zi. Okay. So you may have a different unknown in these other questions. So you're always going to write the unknown variable and then equals, then a formula for what that unknown is. Okay? So I'll show the next one on the screen, and you can work on that. And we're just going to go down, just do the first 3. Just do the first 3, and then don't go on to number 4. Here's a visual for number 2. Here's a visual for number 2. Okay? Here's a visual for number 3. Or something like that. Something close to this. Here's a visual for number 3. Where's Caitlin Rauschenberger? Caitlin, how'd it go? How'd number 2 go?
I got 0.9 for the initial,
ZI is 0.9, okay.
and then I got DZ was 0.5, and I got the final was unknown.
Okay, so then the final's unknown and DZ was 0.5. So going back to that picture, what was that? 0.9. And 0.5, okay, and so then did you find the unknown Z final?
Yeah, so I did Z final equals Z initial plus DZ.
She said Z final equals Z initial plus DZ. Agree with that? And then what is the value?
0.5.
Z
Or 1.4.
1.4. And that formula would be Z final equals Z initial plus DZ. And that should make perfect sense. What you started with plus the amount of change will result in what you finished with. Okay? How about number 3? Where's Tynan? Shiffet. All right. You're up. How'd number 3 go?
Yeah, it is 0.3, yeah, is the 1.2, and the DZ is the unknown. It's, the formula is ZF minus ZI equals DZ, and DZ is equal to 0.9.
Perfect. He said ZI was 0.3, ZF was 1.2, DZ was the unknown, which is calculated by ZF minus ZI, and that value was 1.9. Sorry, 0.9, just 0.9. Okay, I want you to get a partner, and I want you to verbalize to each other. Take turns verbalizing. How is a value of Z different than a value of DZ? This is crucial because students, we've done this many semesters, and when things get confusing, when there's lots of things involved in a couple weeks, this point gets lost, and it's really important that you know the difference between a value of Z and a value of DZ, so you're going to practice saying that to each other, and then write out a good coherent sentence. Go. All right, where's Nicholas Hawk? Nicholas Hawk. All right. What did you say the difference between Z and DZ was? Okay. And? Z is the, okay. Z is the function and DZ is the change. Okay, Z is a variable, but what is the difference? They're both, okay, so, go ahead.
I put that Z is a currently existing value, in this case the storage space, and DZ is the change in the value of Z, causing Z to either increase or decrease.
Right. Z is like the amount. Z is how much space is being used, or like current space. DZ then is representing a change. So the picture is really important here, if you see the picture. So I wanna just tweak this a little bit, or just give you a new thing to think about. So go back to number 1. Go back to number 1. So really what happened? We started at 3 and we ended at 5.5. So let's think of the dynamic process through which that happened. What's happening?
Z is changing as a result of dz increasing.
It's downloading, right? And as it downloads, the current amount that's used is changing. But notice what is also changing as we do it.
dz.
dz is a variable. dz is a variable, and that's still consistent with everything you've done so far. But there's this passing from z initial to z final, and as that occurs, dz varies. Do you see it? Okay, keep going. 4 through 6. Keep going. Okay, watch. So just for number 4 there, watch it. Ready? Watch it. Watch it again. So at first Z was 8.8, and then what happened? So this isn't okay. That's actually not accurate. Oh, yeah. So what should be happening here is, let's see. Anyway, let's do the numbers. What is Z initial?
8.8.
8.8. Z final is?
4.7.
What's DZ now?
ZF minus ZI.
Negative. The change is negative. All right, so I'll get this visual of that tidied up for next week. But the change is negative, and it's negative what? 4.1. How do you compute DZ in this case?
ZF minus ZI.
It's still ZF minus ZI, because ZF is less than ZI, you get that negative change, which means the value of Z decreased. So the value of Z decreases, you get a negative DZ. Okay, so next time I'll see you is Wednesday. You're going to have that activity, very important activity, and then some reading. Just check Blackboard for all the details. Be safe over the holiday.